In this video, we will continue our study of the normal curve by looking at an application problem that we can complete and understand using the knowledge we have of the normal curve. Let's look at the example. It comes right from the textbook. It's a vending machine. A vending machine is designed to dispense a mean of 7 6/10 ounces of coffee into an 8-ounce cup. The standard deviation, the amount of coffee dispensed, is 4/10 of an ounce, and the amount is normally distributed. And what we want to do is determine the percent of times that the machine will misbehave in these different ways. So these 4 questions asking us, how likely is it that the machine is going to do each of these things? Dispense more than 7 ounces, less than 7 ounces, more than 7 7/10 ounces, and then the worst case here, more than 8 ounces, where the cup is going to overflow and make a mess. What percent of the time does the machine do that? What we need to do to complete this example is start by finding a z-score. The z-score can be calculated by using this formula, the value of the piece of data minus the mean divided by the standard deviation. Let's look at the first example. For the first example, that's number 61, and it'll actually be 62 also because those are both using the 7 ounces. We want to find the z-score for 7.0. The z-score for 7.0 can be found by subtracting 7.0 minus 7.6 divided by 4/10, because our x is 7, the mean is 7 6/10, and the standard deviation is 4/10. Notice that when I calculate that z-score, I get negative 1 5/10, negative 1.5. The next thing I need to do is to open the chart, the table, and find what percent of the data is to the left of a z-score of negative 1 5/10. When I look up the chart, negative 1.5, I see that the part of the graph that is to the left of that z-score is 0.0668, or I could translate that to mean 6 68/100ths of a percent. Do you see how I've shaded that here? Now I can answer some questions. I'm going to go out of order and start with this number 62, dispense less than 7 ounces, because I've already calculated the answer to that question. Less than 7 ounces would be this percent we already found, and it looks like that happens 6 68/100ths% of the time, or 6.68% of the times that the machine is used. It's going to give the customer less than 7 ounces. To calculate more than 7 ounces, I have to look a little deeper and see that more than 7 ounces is going to be this section of the curve that's to the right that I'm shading green. And if the entire area is 100%, and I subtract the 6 68/100ths%, that's going to leave me with this green piece, the 93 32/100ths. So that's 93.32%. Again, what I did was I subtracted that 6 68/100ths from the 100 to get 93.32. Let's look at one more question. How often does this machine dispense less than 7 7/10 ounces? Once again, the first step is to find the z-score for 7.7. we can note that by writing Z sub 7.7. And I'm going to fill in the value for the piece of data is 7.7. The mean is 7.6. And the standard deviation is 4/10. When I do that, I get a Z-score of 25 hundredths. And then when I open the table, I find that the percent for a Z-score of 0.25, the percent is 59 and 87 hundredths percent. The decimal number is 0.5987, and I can translate that to a percent of 59.87. So what happens to the left of 0.25 Z-score is 59.87%. And so that is the answer to number 63. There's no further calculation we need to do because the chart just flat out gives us the value for what happens to the left of the Z-score. We have one more question to answer, number 64, and for number 64, we need to start by finding the Z-score for an 8.0 or 8 ounces. When we replace the X with 8, then X 8 minus the mean 7.6 divided by the standard deviation 4/10 gives us a Z-score of 1. And when I look that up in the chart, I see that that's 0.8413, which is 84.13%. And what we're looking for is an overflowing cup. So we're really looking for this area to the right. So you guessed it, we're going to have to subtract, once again, from 100. So I start with 100% of the curve. I subtract the 84.13%, and that gives us our answer 15 and 87 hundredths %. That wraps up this example. I hope that the next time you use a hot beverage vending machine, you don't get an overflowing cup and you don't get an underfilled cup. But this is an interesting example that helps us understand how often those different problems could occur.